Okay, so we're just going to start again by reviewing the difference between all four states. So let's start here with the respiratory acidosis. You know something is acidotic when its pH is below 7.35. So in respiratory acidosis, we have the pH below 7.35, but remember that respiratory is the opposite. So in this case, we have our PaCO2 that's high. So if the pH is low, and we know that the respiratory is the cause, then that means we have more acid on board. And so that means it has to be above 45 millimeters of mercury. So if you look here at the blood gases, you can see that we've got a pH of 7.32, which is going to be below the norm of 7.35. And we have the PaCO2 above 50, which means there's a lot more acid that's going to be in the blood gas. And for this, our bicarb is within the normal range. I'm going to show you down here the normal values. The normal values here are the pH is 7.35 to 7.45. So anything below 7.35, as we said, is going to be acidotic. The PaCO2, it's more basic if it's below 35, and it's more acid if it's above 45. Remember that carbonic acid is an acid. And then with bicarb, the normal range according to your textbook is 21 to 28. At Blue Water Health, it's 22 to 28, and in some other organizations, it's 20 to 26. So anywhere within the range of like 20 to 28 could be normal. In your textbook, it is 21 to 28, and so that is the number that we'll be going with for the purposes of the midterm and exam. Remember also the Rome, respiratory opposite, metabolic equal. So in this case, if we go back to our blood gases, 7.32 is less than 7.35, so we know it's acidotic. PaCO2 is greater than 45, so that means it's acidotic. And our bicarb is normal. So that means that this is uncompensated respiratory acidosis. So why might this be occurring? It's going to be because of a decreased respiratory rate. So you can remember this because the pH is going to be low, and so our respiratory rate is going to be low. Hypoventilation. So anything that causes hypoventilation, like oversedation, COPD, pretty severe pneumonia, or atelectasis could be causing respiratory acidosis. Okay. Respiratory alkalosis is going to be the exact opposite. So in this case, the pH is going to be above 7.45 because it's alkalosis. So it's going to be above the norm of 7.45. Remember that respiratory is opposite, so our PaCO2 is going to be below 35, below our normal range. So remember that we've got this as an opposite effect when it's respiratory causation. So if you look down at our blood gases here, you can see that the pH is 7.35, which we know is greater than 7.45, so that means it's alkalotic. Our PaCO2 is 28, so that's less than 35. Remember, it's opposites. And our bicarb is normal, and so we don't have any compensation that's occurring. So why might we have respiratory alkalosis? So in this case, it would be hyperventilation. Sorry for that weird glare there. Hyperventilation. So you can remember that an increase in pH and an increase in respiratory rate are going to be causing respiratory alkalosis. So it might be a panic attack, anxiety, fever, pain, or some CNS disorders. And so this is respiratory alkalosis. Okay, so let's zoom back so you can see everything here. And then let's move to metabolic acidosis. So remembering with metabolic, it's going to be equal. So with metabolic acidosis, we know that we're going to have an acidotic blood gas. So we're going to start with our pH first, and it's going to be below 7.35. We know that in this case, it's going to be equal. So if our pH is down, our bicarb is going to be down because they move the same way when it's a metabolic causation. And so some causes here are DKA, lactic acidosis, severe diarrhea, starvation, renal failure, and shock. So the pH is going to be 7.22. The PaCO2, or carbonic acid, here is within the normal range of 35 to 45. So it's the causation is not respiratory. And we can see here that our bicarb is significantly below the normal of 21 to 28. And so we know we have a metabolic acidosis. Before we get to the tic-tac-toe, let's just remembering our normal range one more time and go over to metabolic alkalosis. Sorry for that weird glare. Metabolic alkalosis means that the pH is above 7.45. So above our normal range means it's basic. So that's going to be alkalotic. And we know that metabolic is equal. So our bicarb is going to be up or elevated. So our bicarb is going to be greater than 28, greater than our normal range. Okay? So we can see here our pH is 7.58, which is greater than 7.45. So we know that means it's more basic. So that's going to be an alkalosis. Here you can see that our PaCO2 is 45. So it's still within the normal range, although we're getting to a point where we're starting to see that maybe it might be moving towards compensating. And our bicarb is significantly elevated at 30. So it's outside of the normal range of 21 to 28. So we have an excess of bicarb, which is an excess of base, and it's metabolic in cause because it's bicarb. And here we know that it's metabolic alkalosis. So some things that might be causing metabolic alkalosis are prolonged emesis or vomiting, or excessive gastric suctioning or NG suctioning of the stomach, diuretic therapy, low potassium, or increased bicarb. And so that's how we would know that it's a metabolic alkalosis. So remember, respiratory opposite, metabolic equal. Okay, that's how you know what the causation is. Okay, I'm gonna go back over to the alkalotic side. Okay, so let's do our tic-tac-toes here. Okay, this is another way that you can figure out causation. So your pH is 7.58. So we know that that is basic. Okay? We know that our PaCO2 is within the normal range. So we know that it can't be respiratory in causation because it's in the norm. Okay? Remember, you have to have them line up for causation. And our bicarb is 30, which is outside of the normal range. Okay, so we know our bicarb goes here. We have a tic-tac-toe. And so that means we know that bicarb is the cause. So that means it's metabolic, causing the pH to go out of balance. The pH is high, so we know that it's a metabolic alkalosis. How do we know if it's compensating or not? We look to see what the other system is doing. So what's our respiratory system doing? Well, in this case, we want more acid so that we can bring down the pH back within the normal range. And so if it were partial compensation, we might see something like a change in the carbonic acid. We might see an elevated level, which would put it over here, and then that would be partially compensated metabolic alkalosis. Okay, so let's do one more tic-tac-toe over here. So we know that this is going to be an acidosis because our pH is below 7.35. So we've got our pH here. The respiratory carbonic acid is between the normal range of 35 to 45. So we know that it cannot be respiratory causation. And our bicarb, it's outside of the normal range. It's low. So we know that that's going to mean that it's an acid because metabolic equal. Okay, so in this case, we're going to have a tic-tac-toe here on this side, whereas it's bicarb is causation. So we have metabolic acidosis and we have no compensation. Okay, where we might start to see some compensation is if our PaCO2 starts to drop. You know, let's say it goes to like 30. And then that would be outside of the normal range. And so we might start to see partial compensated metabolic acidosis. Okay, so you have to look at the opposite system when you're checking for compensation. There's partial compensation if the pH is outside of the normal range, and full compensation if the pH fully normalizes. So the pH would have to get back to at least 7.35 to have full compensation. Okay? So that's just a complete overview of the 4 states of blood gases. I hope this was helpful.